Are you learning programming or preparing for a technical interview? Measure your progress by solving these tricky programming questions. Give it a try. Let us see whether you can really solve it. Rules are really simple. You get only 2 minutes to solve the problem. You can skip to 3rd minute in this video to find the answer. If you get a right answer, then give this video a thumbs up. If you don't, challenge your friends by sharing this video with them. Most importantly, subscribe to the channel and hit the bell icon so that you get instant notification when we upload the next coding challenge or an informative video. So here we go, do your best. I will see you in the 3rd minute with the right answer. Time's up. Here is the answer. In this section of trick questions, we are going to check few common questions which are frequently asked in interviews, so that can help you prepare for your interviews. So the first problem is to print a message without using any semicolon in the program. There are 3 methods using which we can do. We know that inside of if else, anything that is inside parenthesis as a condition is nothing but an expression. So all the expressions are evaluated to certain value. So when we write printf function inside your if, a semicolon is not required there, and at the time of execution this condition will be evaluated, that is it will be executed and it will print code god first, and after that the condition will be evaluated, then maybe if will execute or not. So once the printing is done, rest of the code will be executed. So for this use case, we are just writing printf statement inside of if and we are writing empty curly braces. In method 2, the same logic can be applied, but instead of if, I'm writing while loop and I'm using not operator over here. So this whole condition is evaluated. For that, this printing is done first using printf and we are just writing not operator. Hence the result will be false and this while loop will be completed. Similarly, in the third method, I'm writing a for loop. The same condition as we wrote in while is here without a semicolon, but this semicolon is not part of your printf statement, but this is compulsory part of your for loop. So here we write initialization, this part is your condition, and after this semicolon comes your increment or decrement part. So technically for printf statement we have not used any semicolon. So this was method 3. Time's up. Here is the answer. In this, we are going to require to print user's entered name 5 times without using a loop. Now, if we are not going to use a loop, then the only alternate way remains is to call a recursive function. So to achieve our result, inside of main, I'm declaring a character array name of size 50 and I'm asking user to enter the string that will be his name. And after that, I'm making the first call of my recursive function. I'm passing my string to it and I'm passing the iteration number. So that is 1 over here. So once the call is made to the function, so my name is here, my current count is here, I am going to print that number. I am going to increment my count by 1. After that, I am writing my condition. So once this condition is false, recursive function won't be called. So if the condition is true, I am making another call. I am passing the same name, but this time current count. So before this call, the number was incremented to 2. So in the second call, count would be 2. So subsequently, third call will be made, fourth call will be made, fifth call will be made. And in the sixth call, this condition will be false and there won't be any further calls. So that is how we can print a given string 5 times without using a loop. Time's up. Here is the answer. I'm asking user to enter a number, and to solve this problem, we just need to check whether the 0th element of the number is 1 or 0. So I'm applying AND operator to number with hexadecimal value 0, 1. If the 0th bit is 0, then we will print number is even, else we will print number is odd. Time's up. Here is the answer. The next program is very commonly asked question that how we can swap two numbers without using a third variable. So logic for this is very simple. So these are my arithmetic statements. Suppose user has entered A is equal to 10 and B is equal to 20. So in the first statement, I'm assigning value of A as A plus B. So A will become 30 over here, and in the next statement, I'm assigning A minus B to B. So A is currently 30. So 30 minus current value of B is 20. So your B will become 10. So if you just check previous value of B, which was 20 and A was 10, so we have achieved result for B. Now our variable A is holding value as 30. So in the final statement, I'm writing A minus B, that is 30 minus 10. So result will be 20 and we are assigning this value to A. So A will become 20. So that is the final step. So this is the method one, that we have swapped two numbers without using a third variable. There is one more method to it, in which I'm just writing this simple statement: A is equal to A plus B minus B equal to A. So again, if value of A was 10 and value of B was 20, so because of this parenthesis, this statement will be executed first. So here I'm assigning A into B, so B will become 20. So first of all, this statement will be executed. So we are assigning value of A into B, so B will become 10 over here. So the first result is achieved, and then because A is assigned to B, so technically for compiler this value is 10. So after that, because we are still in the middle of execution, value of B will be the previous value, that is 20, and then value of A is 10 plus. So A is 10, and because of the execution is still in process, old value of B will be written here, that is 20, and this will be evaluated and 10 will be here. So this 10 and 10 will get cancelled and this 20 will be assigned to A. So after execution of this, A will become 20. So just because of this simple statement, we have swapped value of A and B. Time's up. Here is the answer. So what we have is a main function, and inside of main there is just %s, then code.com. These are three different strings, but notice that there is no comma in between these two strings. So this is just simply as concatenation of two strings or consecutive string just separated like this. So suppose the first string is ABC and second string is XYZ, then actually this is same as ABC XYZ. So in this case, final output would be code.com. Time's up. Here is the answer. Now we'll check the sixth trick question. We are asked output of the following code. So this is our code. Inside of it we have a printf statement where %d and %d are written, and after comma size of is used and code god as a string is passed to it, and after a comma we have strlen function used and the same parameter is passed. So here we know that a character is equal to 1 byte. So we have a string with length 7, so total 7 characters, so which is equivalent to 7 bytes. This will give us 7. Similarly, strlen will be giving us length of this string, that is also 7. So output would be 7 7. Time's up. Here is the answer. In the next question we have this as a program. So the code is inside of if statement we have printf code god. So that will get printed when the condition is going to get evaluated, and this will always return us a true value. Hence this will also be printed. So final output is code god awesome. Time's up. Here is the answer. We have a while loop which has just one in it, and then inside of curly braces we are printing code.com. Now we know that all the conditions are evaluated to a result. So if the result is 0, then that is considered as false, and all the non-zero results are considered as true. So because we have written 1 over here, so technically this is a true condition, and because we have a while loop, so it's an infinite loop. So output of this program is that it will print code.com infinitely. Time's up. Here is the answer. Here we have while loop, and inside of while loop we have a is equal to 0, and the same printf statement is over here. So this condition will be evaluated first. So 0 will be assigned into a. So this statement will be similar to while 0. As we have seen over here, 0 is a false value. So while 0, that means condition is false. So this block will not be executed at all. Time's up. Here is the answer. We have a equal to 0, but notice that this 0 is in single quote, which is equivalent of ASCII character 48. So 48 will be assigned into a. So this statement is similar to while 48, which is a non-zero value. Hence this condition is true. Hence this while loop is an infinite while loop. So output of this program is that this program will print code.com infinitely. Time's up. Here is the answer. So what we have here is main function, and then we are given any number. Here I'm taking example as 147. Then we have another variable as res, which will be storing the result. Then we are checking if number, which is 147, which is a non-zero value, which means this is a true condition. So this code block will be executed. So what we have over here is result equal to number modulus 9. So 147 modulus 9 will give us 3, because 9 16s is 144. Hence we have remainder as 3. So technically this is a condition that we are checking over here. So number modulus 9, that is 3, equal to 0, which is a false condition. Hence this block will not be executed. However, this will get executed. So again, what we have over here is number modulus 9, which we have already done, that is 3. So 3 is the result which will be stored into res. Else part will be skipped. So we are just going to print a result which is 3. So output of this code snippet is 3. Time's up. Here is the answer. Now how we can do that is with using XOR operator. Now in case of XOR operator, we know that when both the digits are same, in that case result is 0, else in other cases it is treated as 1. So suppose we have 10 over here, so binary equivalent of 10 is 1 0 1 0, that is 8 4 2 1, hence 8 plus 2 is 10. So 1010 is binary equivalent of 10. So what we are doing over here is we are applying XOR on X and Y, which are 10. So 1010 is binary equivalent of X and Y, that is 10. So we are going to apply XOR operator over here. So because these bits are same, so all the digits after applying XOR will be 0, which is equivalent to 0 as a decimal value. So X XOR Y will give you result as 0. To this value we are applying a NOT operator. If you check here, we are negating this value. So 0 represents a false value, and when we apply a negation operator, it becomes true. So this whole condition is basically a true. So because this condition is true, this code block will be executed and the program will print X is equal to Y. Time's up. Here is the answer. So what we have over here is a main, then we have integer I, then we have a for loop starting from 0 till 5. Because the condition is I less than 5, so it will be executing from 0 till 4, that is total 5 times. And then inside of this for loop we have int I equal to 10. Now important catch over here is that int I, that is we have declared I inside of for loop. So this I is a local variable for this for loop. So every time when this loop will be executed, compiler is going to declare variable I every time and initializing it to 10. So inside of every iteration of this for loop, it is going to print 10 only. But how many times? 5 times. So output of this program will be 10, 10, 10, 10 and 10. That is total 5 times. Time's up. Here is the answer. So int number is the number that we are going to use. We are asking user to enter value of number and it will be stored at address location of number. And after that we have a statement over here where we are using binary AND operator on number and hexadecimal value 1. So if user has entered, let's say 9 as a value, so binary equivalent of this decimal value 9 is 1001, that is 8421. So 8 plus 1 is equal to 9. So 1001 is binary equivalent of 9. And we are applying hexadecimal value 001. So I'm just writing 001. So we are just ignoring initial zeros over here. So when we apply binary AND over here, we know that 1 and 1 will give you 1, and 0 will be 0, 0 will be 0, 1 will be 0. So in case of AND operator, only when both the inputs are 1 and 1, only then you get 1 as the output. In all other cases, you have result as 0. That is the reason we are applying AND operation on hexadecimal value 1. So in this case, when we apply binary AND operator on given number, for all the odd numbers, we will always have 1 at the end. In this case, for 9, we have 1 at the end. For all the even numbers, we won't have 0 at the end. For example, let us assume user has entered, let's say 12 as input. So binary equivalent of 12 is 1100, that is 8421. So 8 plus 4 is 12. So we don't have 1 at the end. So when we apply AND operation on this number with 0001, so we will get 0 everywhere. Hence, when we have 0 as output over here, so we can say that entered number is even. So for any given number, when we apply binary AND operation with 1, then we can print %d is an even number. When we get 0 adds the output of this condition. Else we can print given number is odd number when result of this condition is 1. Time's up. Here is the answer. So what we have over here is two variables I and j, both are initialized to 2. Then we have a while loop where we have condition inside it I plus 1. So I plus 1 is 3, which is a non-zero number, hence this is true. So output of this will be provided as condition of while loop. So in this case, condition for your condition operator was true, hence I minus minus, current value of I is 2, hence we have 1 over here. So technically this statement is nothing but while 1. So in the first iteration, this condition has become true for while. So we have printf statement inside of this while loop. So current value of I will be printed, that is 1. In the next iteration, the same condition will be checked. So I plus 1, which is 1 plus 1, because current value of I is 1. Hence 1 plus 1 is equal to 2, which is a true condition. After that, minus minus I will be executed, which will make value of I at 0. So the condition for your while loop will be while 0, which is a false condition. So the second iteration of while will not be executed, your while loop will get completed. Hence output of this program is just 1. Time's up. Here is the answer. So what we have over here is three variables: a initialized to 2, b initialized to 7, and c initialized to 10. And in the next statement we have c equal to a equal to b. So a equal to b is a condition. So value of a is 2 equal to value of b, which is 7. So 7 is not equal to 2. So result of this condition is value false. So in C we know that false is represented by 0. So this value will be stored into variable C. So because C has become 0, in the next line we are just going to print value of C, which is 0. So output of this program is nothing but 0 only. Time's up. Here is the answer. We have a printf statement where 3% d are present and we are supplying these values. In the first parameter we have size of 3.14. In the next parameter we have size of 3.14f, and as the final parameter we have size of 3.142 capital L. In all the C program, all the decimal values are considered as a double by default. However, we can explicitly instruct compiler to treat values as a float or as a long double by writing small f at the end of your float constant, or by writing capital L, which is a long double, at the end of your float constant. So the first value is nothing but a double, the second value is nothing but a float variable, and the third value is nothing but a long double. Now the size of functions give you total number of bytes consumed by the given variable inside of parenthesis. So because the first value is double, we have seen in more data types lecture that double takes 8 bytes, float takes 4 bytes, and long double takes 16 bytes. So output of this program will be 8, 4 and 16. Now these values can vary depending on your compiler. Time's up. Here is the answer. So what we have in this code is float me is equal to 1.1, then double u is equal to 1.1, and after that we have if me is equal to u, then we are required to print values are equal, else values are not equal. Now prima facie you might think that this program will give this output because both the variables are storing 1.1, so you might think that this would be the output. However, this would not happen. I'll tell you the reason for that. When we stored real constants, that time in case of float and in double, values are generally stored like this: 1.1000000 and so on, and again for float 1.10000 and so on. But at the end of these digits there would be difference between these decimal places. That is why compiler is going to treat these both numbers as two different values. Hence these values are different, this condition will be false. That is why compiler will print values are not equal. Now to achieve this as your result, you need to typecast these values. That is the only way in which you will get this as the result. Time's up. Here is the answer. So what we have over here is a static int var initialized to value 5. Then we are just going to print value var minus minus. So because this is a post decrement, so value of 5 will be printed first and then decrement will happen. So after printing value of 5, value of var will be decremented to 4. In the next line we have statement if var, which is 4. So we are checking if 4, which is a non-zero value, which is a true. So this block will be executed. Now we are just calling main functions back again. So in this program we are just calling main recursively. So in the first iteration we have printed 5, and because var is a static variable, so throughout these iterations value of variable var will be retained. So there won't be different initialization of variable var in each iteration. So in the next iteration value of variable var, which is 4, will be printed, and again it will be decremented to 3. Again the same call will be made. So this process will be repeated until somehow this condition becomes false. So because we are decrementing value of var in each iteration, this condition will become false only when we have value of var as 0. So in the first iteration 5 was printed, value of 4 was passed. In the next iteration value of var, which was 4, will be printed and it will be decremented to 3. In the next iteration value of var, which has become 3, will be printed and it will be decremented to 2. Similarly 2 will be printed in the next iteration, value of var will become 1, and in the final iteration 1 will be printed and value will be decremented to 0. So after that call to the main function will not be made. So output of this program is 5, 4, 3, 2, 1 because of calling main function recursively. Time's up. Here is the answer. We have long variables sec, hr, min and t. So sec is nothing but seconds, hr is hours, min is minutes, and t is nothing but we are denoting for time. So we are asking user to enter seconds, and we are going to store it into address location of sec, and after that we are going to calculate r is equal to sec divided by 3600. So 3600 seconds is nothing but 1 hour. So when we enter, let's say 7200, which is double of 3600, so we will get output as 2 hours. So HR will become 2. Suppose we had entered, let's say 7212. So again HR will be equal to 2 after execution of this statement. And then in the next statement we have t is equal to sec modulus 3600. Now for 7212 it will give us t equal to 12, as in the previous statement hr was given as 2. After applying modulus operator we will have t is equal to 12. Now what we are trying to achieve over here is, after we get number of hours, we need to calculate minute and seconds. So in variable t we are just storing the remaining seconds that we have after calculating number of hours using seconds. So min is equal to t modulus 60 will give you number of minutes. We are dividing it by 60 seconds only, so we get minutes. So because we have 12 only, so 12 divided by 60 will give us 0 only. So min will be equal to 0. After that we are applying modulus operator on t. So we have 12 modulus 60, hence the output will be 12 only. So SEC will be stored with 12. So at the end of this program, in the final statement, the output would be time is 2 hours 0 minutes 12 seconds. So this code snippet is giving us time in hours, minutes and seconds when input is given in seconds. Time's up. Here is the answer. So in this code snippet, we have value of I initialized to 0, and after that we have j equal to I plus 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 1. So let me break down this statement for you. It is I 3 times plus and then 1. So for compiler, this is one operand, this is the second operand, and this is our plus operator. So 1 will be as its plus, and then current value of I will be taken over here because this is a post increment operation. So current value of I is 0. So 0 plus 1 is equal to 1. So value of j will be initialized to 1. And in the next statement we are printing value of j, that is 1. So output of this program is nothing but 1. Time's up. Here is the answer. We have an array of size 1 and it is initialized with single value 2. So we have ARR of 0 equal to 2. So 2 is getting stored at 0th index of array ARR. In the next line we have 0 inside of bracket ARR. So this is nothing but alternate way of accessing value at 0th index of array ARR. So because we have 2 at the address location of array 0, hence output of this program will be 2. Time's up. Here is the answer. So what we have over here is main function, in which we are calling user defined function sum, to which we are passing the number of which we are going to find sum of its digits. So in the definition of that function sum, we are passing an integer variable. So 143 will be passed over here and it will be stored into x. After that, this is that single statement which will be responsible for performing sum of digits. So we are initializing s with 0. So s we are going to use for storing sum of all the digits from the given number, and this is our condition. We are going to perform this while loop while x is greater than 0. And after that, we have this special instruction where I have used comma operator. So for comma operator, operation starts from left to right. That means that this first instruction will be executed first and then the next one. So in the first iteration, we are doing nothing but we are adding remainder using modulus operator, and in the each iteration, value of that remainder will be added into current value of s. And once that is done, we are dividing number with 10 because we have already added the last digit. So we will be removing that digit from the number. So in the first iteration, when 143 is given number, so applying modulus operator will get 3 as remainder, and because of this next instruction, we will get 14 after dividing it by 10. Similarly, in the next iteration, we will get 4 as remainder and number will be changed to 1, and in the final iteration we'll get remainder as 1 and our number will become 0. So these will be my value of x and s, x, s, x and s. So because in the each iteration we are going to add remainder in the current value of s, because current value of s in the first iteration is 0, 3 will be added over here, hence s will become 3, which will be current value of s in the next iteration. So 3 plus 4 will happen over here and s will become 7, and in the final iteration 7 plus 1 will be executed. So final value of s will be 8. So that is how we'll get sum of all the digits from the given number using this function. So once in the final iteration x becomes 0, this condition will be false, hence this for loop will be terminated. And after that, we are simply returning value of s, which is 8, and that will be printed over here. So output of this program will be 8, and this is how, using this single instruction, we have performed finding sum of digits. Time's up. Here is the answer. So we have integer a declared over here, and then we have a if statement. Inside of if statement we have a equal to printf hello world plus 4. So let me break down this statement for you. We have a equal to printf hello world plus 4. So we will take 4 as it is, plus we have printf hello world. So this function will give me 10 because length of this string is nothing but 10. So printf usually gives us number of characters that it is going to print. So it will give me 10. So finally we have a is equal to 10 plus 4, that is 14. Now we are applying if on this output. So if 14 is something that compiler will be calculating. So 14 being a non-zero number, this statement will be considered as true. Hence the controller will go inside of this if statement and it will print value of a, that is 14. So output of this program is 14. Time's up. Here is the answer. So this is the given code snippet. We have three variables a, b and c. A and b are both initialized to 1, and then we have this statement. So this statement is nothing but a plus plus minus plus plus b. So in this operation, value of a and b is going to increment. So current value of a and b is 1, hence a and b will both become 2. But because a plus plus is post increment, hence current value of a will be utilized, that is 1. And here, because it is pre increment, so incremented value of b will be utilized, that is 2. And because we have minus sign over here, so this statement will give us output as 1 minus 2, that is minus 1, and this value will be stored into variable c. So c will be minus 1. Okay, so we have got values of all three variables. C is equal to minus 1 and a equal to 2 and b equal to 2. And in the next statement of program, we are just printing these values directly. So current values of a, b and c will be printed. So output here will be 2, 2 and minus 1. And notice that we have a comma over here, so a comma will also be printed. So output is 2 comma 2 comma minus 1. Time's up. Here is the answer. So we are given this code snippet in which we have two variables a and b. Both are initialized with value 10. After that we have one if statement in which a is equal to 5 is written. Because this is a single equal to which is assignment operator, so value 5 will be stored into a. So because condition is evaluated as if 5, so 5 is a non-zero number, hence it is a true value. So because it is a true condition, so this statement will be executed. Because this if does not have any parenthesis, so this single statement will be used as your if block. So the statement is b minus minus, so current value of b will be decremented, so b will become 9. And after that we have a printf statement where we are printing two values %d, and first value is passed as 10, which is value of a, which was changed inside of if statement. So 5 will be printed, comma, and we have b minus minus over here. Now here value of b will be decremented and it will become 8. Because it is post decrement, current value of b will be utilized for printing purposes. So 9 will be printed over here. So this is our output of this code snippet, and at the end of the program value of a will be 5 and b will be 9. Time's up. Here is the answer, in which value of I is initialized with 2, and after that we have int j is equal to plus I plus I. Now if we break down this statement, we know that the values will be evaluated from left to right, hence the first operand is plus I. So current value of I is 2 and pre-incremented value will be 3, hence 3 plus the new value of I, and the second operator is I, that is new value of I, which is 3, hence output of this program. So 3 plus 3 is equal to 6, and in the next line we are just going to simply print j. So because this 6 was assigned to variable j, so this statement will print output as 6. So output of this program is 6. Time's up. Here is the answer. So this is the given code snippet, and here we have value of x initialized with 011. Now in C programming, when we write number in this format, this is nothing but a representation of an octal number. Hence, when we write 011, it is nothing but 9. So when we initialize x with 011, we are indirectly initializing with equivalent value 9 as a decimal number. So 011 as a octal value is equal to 9 as a decimal value. In the next line we have a for loop where I is initialized to 0 and we are checking condition as I less than x. Because I is initialized to 0, so we are checking condition as 0 less than 9. Because this condition is true, so for loop will be executed. So inside of for loop we will be printing code.com. After that we have a continue statement, because of which the subsequent lines of code will not be executed. Hence the controller will go back to the top again and it will increment the value of I to 3. So in the second iteration again the condition will be true because 3 is less than 9. So again code god will be printed for the second time, and again because of this continue, controller will go back to the starting of the loop. In the next iteration, value of I will be incremented to 6. So again the condition will be checked as 6 less than 9, which is again a true condition. Hence the controller will go back again inside of for loop. It will print codegod.com for the third time, and after that because of continue it will go back to the top. Now in this case, when value of I is incremented to 9, the condition will be checked as 9 less than 9, which is a false condition. Hence this for loop will be terminated. After that we are just returning value as 0. So output of this code snippet is codegod.com. It will be printed 3 times. Time's up. Here is the answer. We have I and j as two variables. Notice in the next statement we have I equal to j equal to 3. So what is happening over here is 2 will be stored into j and the same value will be stored into I. So I and j will be initialized to 2. Comma 3 here is a valid statement, but it won't have any impact on these variables. So in the next line we have while loop where condition is minus minus I and j plus plus. So the condition would be something like this, while, and inside the bracket, because Here we have pre-decrement, so current value of I will be decremented, so decremented value that will be 1 will be utilized, then ampersand ampersand. Then we have post increment over here, so current value of j will be utilized as it is, hence it is 2. So this will be the condition that will be evaluated, and after checking this condition, I will be 1 and j will become 3. I will be decremented because of decrement operator over here, and j will be incremented because we have post increment over here. So 1 and 2 both are non-zero numbers, so technically these are true and true. So when we apply AND operation on two true values, we get result as true only. So we are checking a true condition, hence while loop will be executed. So inside of while loop we are printing values of I and j. So in the first iteration 1 and 3 will be printed. Then in the next iteration again we are going to use decremented value of I, that is 0 ampersand ampersand current value of j, that is 3. Here value of I will become 0 and j will become 4. Here 3 will be utilized because the instruction is post increment, hence current value will be used. So now in the second iteration we have 0 and 3. So because this is a 0, that is a false value, and 3 is a non-zero, which is a true value. So in case of while loop, when either of the value is false, so condition will be treated as false. So second condition will be false, hence the while loop will be terminated, and after that our program will end. So output of this program is when we print 1 and 3 in the first iteration. So output for this program is nothing but 1 and 3. Time's up. Here is the answer. We are given this code snippet. So we have a static integer I. So we know that for static variables, values are initialized to 0, hence I is equal to 0. Then we have a for loop where I'm writing first statement as plus plus I. So I will be incremented to 1. Then we have another condition plus plus I. So I will become 2 over here. Now condition that will be checked here is the incremented value of I, that is 2. So 2 is a non-zero number, hence condition is true. So inside of for loop we are just going to print value of I. So current value after these two increments, it is 2. And condition as if I is equal to 4, then break. So this break will be executed only value of I will become 4. So before next iteration value of I will be incremented, so it will become 3, and again the condition will be checked. So because we have plus plus I here, so incremented value of I, that will be 4, will be checked. Now 4 is a non-zero number, again the condition is true. I has become 4 here before checking the condition. So after that, value of I will be printed over here. So 4 will be printed, and because now this condition will be true, I is equal to 4 is true, so this break will be executed and this for loop will be terminated, and that will end your program. So output of this code snippet is 2 space 4. Time's up. Here is the answer. So this would be our array elements. So this is our main function, and inside of main function we have argc and argv, which is completely optional. We can skip this part, and we have our integer array after that. So we have 40 values over here. So starting from 1 till 40. So these are 40 values, and compiler will store it from address location of 0. So x0 equal to 1, then x1 equal to 2, and so on till x39 equal to 40. So after that we are calling this function print array, and we are passing our array to it, and we are also passing value 40 to it. So let us see definition of this function print array now. So inside of print array we have a local array variable and then another variable int size. So size basically size of your array. So after that we have one constant n initialized with 10, and after that we have another variable which will require for looping through our array elements. So we are going to use variable j, and after that we have our for loop. So for loop is this block. So we are initializing j with 0, and then we are going to iterate from 0 till 40. So this loop will execute from 0 till 39 because we have condition as j less than size. So condition is 0 less than 40, hence loop will be executing for 40 times starting from 0 till 39, and after each iteration we are going to increment value of j by 1 using j++. So inside of this for loop, we are printing ARR of j. In each iteration, we are going to print current array element. So j will be your index. So starting from 0, it will print values till 40. Because we are required to print 10 elements in each line, so we will have one if block after this printf statement. So the condition would be if j modulus n, so j modulus 10 being a constant, it will be always 10. We are checking whether it is equal to n minus 1. So because n is 10, so we are going to check whether j modulus 10 is equal to 9 or not. So 10th value in our array would be this value, but it will hold index as 9. So when we reach on index 9 and when it gets applied with the modulus operator along with 10, then we will get remainder as 9. So all subsequent indexes like 9, 18, 27 and 36, in this case we will get remainder as 9. So on all such true cases, we will print a /n. So that will bring cursor to the next line. That is how we can print 10 elements on each line. Time's up. Here is the answer. We have this user defined function and we have a main function. So inside of main function we have an integer array of size 2 by 3. So we have array something like this, 2 rows and 3 columns. After that we are calling our user defined function, and to user defined function we are passing array by address. So here we have an integer array pointer that will be pointing to this array. So inside of our user defined function we have integer I equal to 10, j equal to 2, and we have one more variable k. So these are local variables for our user defined function foo. After that we have three statements where arr 0 equal to address of I is written. Now notice that our array is two-dimensional array, however we have written only single dimension over here. So when we write a single dimension only, then second dimension is considered as 0 always. So technically what's happening over here is arr 0 0 is assigned value of address location I. So address location of I is this value, and because it is being stored into arr 00, which is your local array pointer, hence indirectly you are assigning value at this location to your original array from the main function. So in the first column it will become 2. Similarly, we have arr1 equal to address of j. So arr00 will become 10. Similarly, arr10 will be updated because of this next statement, because the code written is arr1 equal to address of j. So that is nothing but indirectly storing value of 2 into original array from main function. So this part will become 2. And the next statement is star arr0 equal to 2. So this is nothing but value at address location of 0, and we are assigning it the value as 2. So your original variable will be overwritten with 2. So this first column has become 2 and 2. So after that we have one for loop where loop is written as k equal to 0, k less than 2. So loop will be executed from 0 till 2, and because we have less than condition over here, so this we will have one less iteration over here, hence for 2 times it will execute for 0 and 1. So inside of this for loop we have star arr k. So what compiler is going to do over here, it is just going to print values from your first array. Because there is no second dimension specified, so 0 will be considered. So arr0 will be printed, and after that in the second iteration arr0 1 will be printed. So output of this program will be 2, and because of this /n, controller will go on to the next line and it will again print 2. Time's up. Here is the answer. So here we have statement as a equal to 1 comma 2 comma 3. Now in case of comma operators, if those are used along with parenthesis, in that case, because the execution will be done like this, priority will be given to the last element. So because there is no expression, so there is technically no output of these first two instructions. Hence a will be assigned a value as 3. If we do not have this parenthesis, then case would have been different. A would have got value of 1. So because a is assigned value of 3, in the next line compiler will print value of a, which is 3. Time's up. Here is the answer. We have four variables: a equal to 2, b equal to 2, c equal to 0, d equal to 2, and m. After that we have one arithmetic statement. So let me break down the statement for you. So m equal to current value of a, that is 2, ampersand current value of b, that is again 2, then ampersand current value of c, that is 0, or current value of d, that is 2. So output of this whole execution would be a non-zero value, because 0 or 2 is true, and 2 is a non-zero value, hence it is also true, and again 2 is non-zero value, so it is also true. So we have all conditions evaluated as true, hence m will hold result as true. Now in C we know that 0 is a false and 1 is a true, so this value will be assigned to variable m. Because of this statement, all these variables are incremented by 1. So when we are going to print value of all the variables on the next line, we will have incremented value of a as 3, b as 3, c as 1, and d as 3. And because m was assigned 1 after executing this statement, so 1 will be printed over here. So output of this program will be 33131. Time's up. Here is the answer. So we have I equal to 5 over here. Then we have statement A equal to minus minus I plus minus minus I. Now notice that there is a recurrence of I twice over here. So in such cases, to remove ambiguity, precedence is given to increment or decrement order. Now because we have a decrement operator here along with plus sign, so compiler in this case will execute minus minus I twice. Because of this minus minus 5, it will be decremented to 4, and again because of this minus minus I, it will be decremented to 3. So compiler will perform arithmetic operation as 3 plus 3, and this will be assigned to A. So A will become 6. So after that we are just going to print value of A. So A will be printed as 6. So output of this program is nothing but 6. Time's up. Here is the answer. So we have a variable x equal to 10 and we have a while loop in which we have a condition as x minus minus greater than 0. This can be also read as x goes to 0. So technically this statement is x minus minus greater than 0. However, for compiler, this and this is not technically different. So compiler is anyways going to execute this. Hence, because we have a while loop, so current value of x will be used to evaluate the condition. So value of x is equal to 10. So condition will be checked as 10 greater than 0, which is a true condition. And after that, value of x will be decremented. So x will become 9. So because 10 greater than 0 is a true condition, hence this condition will be true. And in the first iteration, value of x, which is decremented value because of this minus minus, will be printed, that is 9. So in the first iteration 9 will be printed. In the next iteration, value of x, which is 9, will be checked with this 0. So 9 greater than 0 will be checked and value of x will become 8. So this condition is true. So compiler will go again inside of this loop and it will print 8. So this process will continue till the point we have 1 greater than 0, which is again a true condition, and after that x will become 0, a 0 will be printed, and when in the next iteration condition is checked as 0 greater than 0, that time the condition will be false, but value of x will be anyways decremented to minus 1, and because the condition is false, this statement will not be executed. So compiler will print digit 9 till 0. Notice we also have a printf /n over here. So once this is printed, console will move on to the next line and the program will be terminated. Time's up. Here is the answer. We have two character arrays. Both are initialized with certain value, aptitude in C, aptitude in C. Now in the next line we have condition as ARR1 equal to ARR2. So prima facie this might look that this condition is true, however it is not. For a character array, when we consume it like this, so this is nothing but we are instructing compiler to use address location of this character array. And because these are two different arrays, so ARR1 holds different address value and ARR2 holds different address value. Because these are two different address values, so these values cannot be equal. Hence, this condition is false and compiler will not print anything. So there is no output of this program. Time's up. Here is the answer. We have another code snippet in which we have two integer arrays. So though we have specified size at 3, we have just specified two values. So hence the third value will be some garbage value. But in the 0th location and first location, we are storing these values. But now notice that what we are storing /0, a character value, and it will be stored as an integer because this is an integer array. Now you'll find plenty of articles wherein /0 is blindly taken as 0, which is true, but I'll explain you how compiler perceives this value. /0 is basically a escape sequence, so we know that slash followed by any number is considered as an octal value. So because 0 in decimal 10 is equivalent to 0 as octal value, hence this is nothing but octal equivalent of 0. So technically what we are trying to do over here is we are just storing all the values as 0. So s of 0, s of 1 both will be holding 0. Similarly x of 0 and x of 1 will also be holding 0. So in the next line we have another variable declared as integer where we are writing s1 and x0. So we know s1 and x0 both are 0. So addition of these two array elements will be 0. And in the next line we are just printing value of c, which is 0. So output of this program is nothing but 0. Time's up. Here is the answer. And here we can see we have a while loop and we have two negation operators, and then we have 7. We know that 0 represents a false in C language, and any non-zero number is considered as true value. When we write negation operator with 0, this is nothing but negation of false, which is true. Now when we have two negation operators, something like this, then a 0, so this is nothing but negation of false, which is equal to negation of true, which is equal to false. Now because we have double negation of 7, so this is nothing but double negation of a non-zero value, which is nothing but double negation of true, which is equal to negation of false, which is nothing but a true. So output of double negation 7 is a true value. So because this condition is true, so what we have here is basically a condition which always be a true, and because we have used this condition inside of a while loop, so we are instructing compiler as while true. So this become an infinite loop technically, because this condition is going to be always true. So compiler will infinitely print this string. So technically this program will never end, it will keep on printing this part. Time's up. Here is the answer. In this question we have a very interesting case. We have seen similar problem earlier, but those were little simpler than this one. We know that increment or decrement operators have higher precedence than arithmetic operators. So in this case we have given arithmetic operation in conjunction with pre-decrement operator. Now it is obvious that pre-decrement will be executed first, but output of this program will vary across compilers. The reason for that is the way compilers are built to process these type of instructions, where sequence is not proper. So sequence is something that is decided using expression trees. So suppose a plus b is a given expression, then expression tree is drawn of this format. So system programmer might write program in such a way that either this operator will be processed first and operand will be read later, or they can read operator first and perform operator later. So traversal could be in order, pre-order and post order. Now based on this traversal, an arithmetic expression is formed, like plus AB or AB plus or A plus B. So how to process a given expression is basically job of system programmer. So compilers are basically nothing but system programs which are built based on some traversal logic. So that is why all the compilers will have different traversal logic. Hence the same code snippet will give you different output across different compilers. One way to solve this problem would be that either all the precedence will be executed first, that is, all the minus minus I will be executed. So we have 4 minus minus I. So if initial value of I is 5, then 4 times subtracted value will make I equal to 1. Now this decremented value will be replaced everywhere. So 1 minus 1 minus 1 minus 1. So these two will be get cancelled and value of A will become minus 2. Now this can happen on a certain compiler. Other way to solve this, which is usual in current version of GCC compilers, evaluation of this expression will start from left to right. Just to understand how execution will be done, I'm going to write how compiler will be processing the information. It is not necessary that a similar expression T will be drawn. So compiler will try to execute minus minus I, which are first two occurrences over here, and it is going to perform a minus operation on it. Now whatever the result which is achieved over here, that will be used with this next parameter. So again a minus minus I, and whatever the result of this and this, that will be again subtracted because of this minus operator. And after that we have another minus minus I. So I'm again going to write a minus and minus minus I. Now because these two are at the same level and because we have pre-decrement, so if current value of I is equal to 5, so decrement will happen first, which will make value of I to 3. Now this value of I will be used on this operator, which will give us some result at this step. So 3 minus 3 will be 0, but remember that your I is still equal to 3. Now in the next step this value will be used, and because we have minus minus I over here as a second operand, I will become 2. So this decremented value of 2 will be used on 0. So 0 minus 2 will give us minus 2. Now in the next step we have minus 2 as first operand and we have minus minus I as second operand. So because I is currently 2, it will be decremented to 1. Now minus operator will be executed on minus 2 and 1. So minus 2 minus 1 will give us minus 3. So current versions of GCC compiler will probably give you output as minus 3. Now again, it is not necessary that you will get minus 3 always. So in the interview questions you might answer this question that, if similar kind of situations are there, then output will depend on the compiler. But in case you have certain option in it, then you might want to choose execution of GCC compilers. The reason is that most of the times when questions are prepared, examiner might have used GCC. But in case of oral interviews, the best answer would be that the output will depend on compilers. We are going to solve few more problems like this, so that will make your concept more clearer. But as I said, I'll be using GCC compilers for my explanations. Time's up. Here is the answer. Here we have a structure, struct student, and in which we have two data members A and B, both are integers. After that we have struct underscore var space, inside of bracket two values are provided, 2, 3, and inside of main we have printf statement wherein 2%d are present, and then to this structure variable its data members are printed with the dot operator. So struct underscore var dot a and struct underscore var dot b are supplied as parameters to this printf statement. Now we might think that it will print just 2 and 3. However, the case would not be that. Compiler will give a compilation error over here because this code snippet does not have a equal to sign over here. Now because this equal to sign is not there, compiler will give you an error that equal to sign is required over here. So if equal to was there, then 2 and 3 would be the output of this program, as 2 will be assigned to A and 3 will be assigned to B for struct underscore var. Hence 2 and 3 could have been printed over here, but unfortunately as equal to sign is not there, so this code snippet will give a compilation error. Time's up. Here is the answer. We have an integer initialized to 5. Then we have a printf statement %d code god plus 2 comma a. Now notice that we have plus 2. So this is the first complete parameter, %d code god plus 2. So for the compiler, when we pass something like this, so it skips those number of locations starting from 0 from the given string. So our given string is %d code god, and outside of this string we have plus 2. So starting from 0, 1, 2, 3 and so on. So we are instructing compiler that start printing from second location. So 0th and first location will be skipped and only this part will be considered as the string to be printed. Now because only this remain as the string that will be consumed by our compiler, which does not have any %d remained in it, so the value of a which is supplied over here will not be used. So output of this program will only be code god. Just for the additional information, in case we had statement like this, printf %d code %d god, then plus 2 comma a. So in this case, again this 0th and first location will be skipped, and compiler will have code %d god to be processed, to which this value will be passed. So in this case, output would be code. So %d will be replaced with value of a, which is 5. So code 5 god. But in the given code snippet, output would be code god. Time's up. Here is the answer. Here we have a character string of size 10, and we have a printf statement where %d is specified, and after that a comma is there, and we have printf statement in which code god is supplied. So how compiler will execute this? So once %d occurs over here, so compiler is going to obviously evaluate this. So obviously, because it's a printf statement, so on the console screen code god will be printed first. Now we know that printf statement returns us number of characters that it has printed. So in this case, length of this printed string is 7. So 7 will also be printed on the output screen. So output of this program would be code god 7. Notice that code god is printed first because it was part of this printf statement and it was evaluated first, and after that 7 is printed, which was output of this printf statement. Time's up. Here is the answer. We have a variable I initialized with 5, we have another variable j, and then we have one complex arithmetic instruction. Now I have simplified the arithmetic instruction for your understanding like this. Even when you write statement like this in any of your development environment, it might give you an error because this can result into an ambiguous arithmetic instruction. So you might have to add these spaces like this, which I have added over here. So that is the only way using which your compiler will understand that these are my pre-increment operators. Like in this case, if there are 3 plus in continuation, and if we did not add any spaces over here, so your instruction would be like this, plus plus I plus plus. So in this case, compiler will not understand whether to consider here pre-increment or post-increment. That is why it's better that we write spaces over here. Now assuming that this program had these spaces, so as we have seen in one of the earlier programs, question like this will have different outputs across different compilers. Now for explanation, I'm going to use GCC compiler. So in GCC compiler, first this value will be evaluated, and this plus will be my first operand, to which my operators would be plus plus I, and second is as well plus plus I. Now whatever the output which comes over here will be again added, that is because of this sign with this part, so plus plus I. Now because these are pre-incremented, whatever the current value of I is, that will be incremented immediately because these are pre-increment operators, and incremented value will be utilized by plus operator. So because I is 5, so after executing both the statements, I will become 7, and this incremented value will be utilized by this plus sign. So 7 plus 7 will give us 14. So this 14 will be used by this operator now. Again, because I was incremented to 7 in the first step, here I will become 8. So for this plus operator, output would be 14 plus 8, which is equal to 22. And this 22 will be stored into J. Now we know that I was finally incremented to 8. So J is equal to 22, I is equal to 8. Hence, in the next line, when printf statement is used, I will be printed as 8 and J will be printed as 22. So output of this program will be 8 and 22. Again, just to clarify, this would be the output in case of GCC compilers only. On Turbo C or under your code block, output could vary. Time's up. Here is the answer. We have a character variable initialized to value 125, and then we have c is equal to c plus 10. Now we know that size of a character in C is 1 byte, which is equal to 8 bits. Hence, possible combinations of 2 raised to 8 is equal to 256. Now, because this is signed character by default, because 256 is the maximum size that can be stored into a single character, and because we don't have any signed or unsigned keyword over here, so compiler will assume it to be a signed character. Hence, possible combination that we can have over here is from minus 28, minus 127, minus 126, and so on. Then we will have minus 3, minus 2, minus 1, 0, 1, 2, so on till 127. We have one less positive combination, that is we do not have 128 over here because a space is occupied by this 0. Now coming back to this program, we have C initialized to 125. Now when we are incrementing this value by 10, so C will become 135, but however this is higher than 127, which is the max value that this character can store. So in such cases what happens is the value is circularly rotated. Now what happens, it technically does not get circulated, but for your easier understanding I am going to explain you that from 125, so starting from 125, 126 and 127, these are two combinations, then it will start back from here. So this would be your third increment, this would be 4, this will be fifth, and so on. So because 2 were consumed over here, this direction will end at minus 121. So after adding 10 into 125, we are technically storing minus 121 into this character value. So output of this program when C is printed as an integer will give you minus 121. Just to again clarify, so suppose C was initialized to, let's say, 125, and when you add 2, it can store 127, but when you add 3, it will become minus 128, and when you add 4 into it, it will become 127, and so on. So that is why when we add 10 values, so our result is coming out to be minus 121. Time's up. Here is the answer. Here we have a character pointer str equal to a string which just have a single character x in it. Then we have another variable char c. It's a single character variable and it has single character x in it. After that we have a character array of size 1, and after that we have arr0, that is the first location, which is the only location in this array, and we are assigning c, which is a variable of type character which has a value x in it, and that will be stored into array location 0. So arr0 will become x, and after that we have a printf statement where %d and %d is printed, to which these two parameters are supplied. So in the first parameter we have str length, to which str is passed, which is character pointer and which has x as a string in it. So length of this is 1, and after that we have str, and to which an array is passed which also has size 1 as specified over here. So output of this program will be 1 1. Time's up. Here is the answer. We have a integer k initialized to 5, then we have k++, which should make k to 6, which should increase value of k to 6 and then print. However, it won't be like that, because here we have declared integer constant and not a normal integer. When you add keyword constant, this value cannot be changed throughout execution of your program. So technically it will give you a compiler error that this is a read-only value and it cannot be changed. So this program will not execute, it will give you an compiler error. Technically value of a constant can be changed, but that depends on how code is written. However, in this case it cannot be changed. Time's up. Here is the answer. We have three integers a, b and c. Both are of type integer. A is initialized to 10, b is initialized to 5 and c is initialized to 5. After that we have another variable d and we have an instruction over here. So in the instruction, because parentheses are given, so obviously this part will be executed first. So we have b plus c. So these two will be added. So that is b plus c. So 5 plus 5, that will give us 10. Then this part will be evaluated. So a is 10 equal to 10. That is this output, which is a true condition. Now in C language we know that a true condition is represented by value 1. So outcome of this is nothing but 1. So this 1 will be stored into variable d. After that we are just printing %d, hence output of this program is nothing but 1. Time's up. Here is the answer. So this is the next question, and we have integer I initialized to 0. After that we have declared another variable integer x equal to I plus plus. Now because we have post increment over here, so current value of I will be stored into x. So x will become current value of I, that is 0, and I will be incremented with 1. So from 0 it will be incremented to 1. After that we have y equal to plus plus I. Now because in the previous declaration I has become 1 now, and because we have a pre-increment over here, so pre-incremented value of I will be given to y. So y will become 2 and obviously I will become 2 as well. After that we are printing value of x and y using this printf statement. So output of this program will be value of x and y, so that is 0 and 2. Time's up. Here is the answer. We have our main function, then integer x initialized to 97 and integer y equal to size of x plus plus, and after that we are just simply printing value of x. So we know that size of operator gives us size of the specified variable inside of parenthesis. So in this case we have x plus plus. Now you might think it will give you the size of integer, which is correct, but it will also increment value of x plus plus. So 97 will become 98 and it will be stored into x. But this is something that will not happen. According to C99 standard, if the type of operand is a variable length array type, then in that case the operand is evaluated. Otherwise the operand is not evaluated. In our case, our operand does not have variable length, so it will not be evaluated. So x plus plus will not be executed at all. Alternately, if we had some dynamic array over here, in that case the value will be evaluated. However, because value will not be evaluated, so x plus plus will not be executed. Hence value of x will remain as it is, that is 97. So in this statement value will be printed as 97. Time's up. Here is the answer. So this is the given code snippet. We have seen similar problems, so let me break down this statement for you like this. So this is the given arithmetic equation. We have I initialized to 5, so I have broken down this statement into these plus signs. That is how the compiler will process it. As mentioned earlier, different compiler could have some different output for the same code. So I'm going to consider GCC compiler for this example. So these two will be used first by the compiler for the execution. So this operation will be performed first. So this is my plus sign, then I plus plus and plus plus I will be performed, and whatever the output comes, so this will be executed with the output of this result, and it will be added with I plus plus. So because I is 5 and we have post increment over here, so 5 will be utilized over here. However, I will be incremented to 6 because we have a pre-increment over here. So pre-incremented value, that is the incremented value, which will be 7, will be utilized over here. So here we will have 5 plus 7, that is equal to 12 and I will be initialized to 7. So this 12 will be utilized as first operand for this plus sign. Then we have again post increment over here. So existing value of I will be utilized, that is 7. So 12 plus 7 will be performed over here. So we will get result as 19 and value of I will be incremented to 8. So this will be the final value of I and this 19 will be stored into J. So J will become 19. So once this execution is done, we have a printf statement where I and J are printed. So output of this program is 8 and 19. Again, remember that this is not the actual output that all the compilers will give. This is the case when we are using GCC compiler. In Turbo C compiler or in some other versions, output could vary depending on the expression each compiler is going to process. Time's up. Here is the answer. We have three different variables a, b and c. A is initialized to 10, b is initialized to 20 and c is initialized to 30. After that we have a printf statement wherein 3% d are there, and then we have three calculations as a parameter to this printf statement. So remember, always in case of printf, evaluation will be start from right to left. So this will be calculated first, then this, and then this. So in the first parameter we have c is equal to c multiplied by 2. That will make c equal to 60, and which will be utilized for printing over here. After that we have b equal to b multiplied by 2. So current value of b is 20, so b will become 40, and the same value will be used to print it here. And after that we have a plus b plus c. So value of a is 10 plus new value of b, that is 40, plus new value of c, that is 60. So output here will be 110. So because we have %d dot dot space %d dot dot space %d, so output would be 110 dot dot space 40 dot dot space 60. And because of this slash in, cursor will move on to the next line. Also we have a new line character over here, so obviously from the first position cursor will move on to the next location, it will print everything, and again it will move on to the next line. Time's up. Here is the answer. We have another code snippet in the next program wherein we have a character pointer and it has a string initialized as Linux, L capital. After that we have a printf statement. There we have /n, then a starting square braces, %d, %c, ending parenthesis, then /n. The similar format is also on the next line. However, the parameters that are being passed to printf are different. In the first parameter we have star ptr plus plus. So this is nothing but value at pointer location. So because we have star ptr plus plus over here, so we just need to bother about star ptr, because as this is post increment, so only star ptr will be consumed over here. So pointer ptr is pointing to this string, hence here this will be printed, that is capital L inside of square bracket. And because it has got incremented because of this plus plus sign, that is an increment operator, so it will move on to next character, that is I. So when we print star ptr on the next line, it will print I in square bracket. So this is the output of this program. Notice that because of this /n, cursor would be at this location first. So suppose this is your output screen, then cursor would be at this location first. Because of this /n, it will move on to this line. It will print starting square parenthesis L, then ending square parenthesis. After that, because of this /n, it will move on to the next line. Again, because of this /n, it will move on to the next line, and it will start printing square bracket I, ending square bracket. It will move on to the next line, and because of this final /n, it will stop over here. So this would be the output of your program. Time's up. Here is the answer. We have an array of size 3 which is initialized with 10, 20 and 30. We have another variable initialized to 0, that is x, and we have an arithmetic expression which is this. So let me break it down for you. Compiler will execute this part first because this is one operand, this is your operator, and this is another operand. So plus is the operator. First operand is plus plus arr of plus plus x. Notice that plus plus x is acting as an index over here, and then we have another operand, that is plus plus x. Now whatever the output that comes over here, it will be added because of this additional operator, that is again a plus sign, and it will be added to ARR of minus minus x. So let us see how compiler will execute this operation. So because this is your first operand, so index needs to be calculated at first in order to get this result. So plus plus x will make x equal to 1, and because it is pre-increment, so incremented value, that is 1, will be utilized as plus plus ARR of 1. Now let us see what ARR of 1 is. So this is 0th index, this is first index, and this is second index. Because it is ARR 1, so we are talking about 20 over here. Now because a plus plus is also added over here, so this will pre-increment value of ARR 1 to 21. So technically this will make your array as 10, 21, 30. After that, another plus plus is over here in the second operand, so it will increment value of x to 2. So x has become 2 over here. So because we have got 21 in the first operand and 2 in the second operator, we will get 23 as a result over here. Now in the second operator we have ARR of minus minus x. Now we are talking about pre-decrement over here. So value of x will be decremented first. So currently it is 2. So we are talking about ARR of 1 over here, and x will become 1. So ARR of 1 is nothing but 21. So 21 will be utilized over here, and it will be added with 23. So output of this whole equation will be 23 plus 21, that is 44. And this value will be stored into x because we have x equal to this equation over here, and output of this whole equation is 44. So x will become 44, and on the next line we are printing 44. Time's up. Here is the answer. We have a forward declaration of a function sq, which is defined later in the program. So after that we have a main function in which we have variable a equal to 1, and after that we have an arithmetic statement. So let me break this down for you. So this would be your first operator, this would be your second operator. So sq plus plus a will be added with sq of a plus plus, and whatever the result comes, that will be added into sq of a plus plus. So this will be addition again, and whatever the result of this equation is, it will be stored into x and it will be printed. So let us see how this will be executed. Initial value of a is 1. So as we have specified plus plus a over here, so sq of 2 will be executed. So once 2 is passed into this function, it is just returning you multiplication of that number, that is a square of that number. So we will get 4 over here as output, and value of a will be incremented to 2. For the second operand now, because it is a post increment, again it will give us 4, but it will increment value of a to 3. So a will be incremented to 3. We have 4 over here. We also have another 4 over here. So 4 plus 4 is 8. So this 8 will be added with this value. Now let us calculate this. We know that a is equal to 3 now. So sq of 3 will be called, and we will get 9 as the output over here, and a will be incremented to 4 because of a post increment. So because we have got 9 over here, so this 9 will be added with previous value 8. So we will get 17 as the output. So this 17 will be stored into x, hence output of this program will be 17. Time's up. Here is the answer. We have float x, and x is equal to 0.35 double equal to 3.5 divided by 10. Now we know that float divided by an integer will give you a float only. So what is happening over here is 3.5 is being divided by 10. That will give you 0.35, and because it is equal to this value, so this being a condition, because of this double equal to, it will give you a result as a true value, and we know that true is represented as 1 in C language. So x will be assigned value 1. Now because x is a float variable, as we can see here, it will not store 1, but it will store 1.0000. So output of this program is this. So this formatting again depends on your compiler version, but output will be 1.0000. Time's up. Here is the answer. So this is the given code snippet, and we have integer I, then we have a function. This is forward declaration of a function, so that function can be defined after your main function. So inside your main function we have a while loop. Inside it, variable used is I. So because I is a global variable over here, in C language, global variables are assigned value 0. So hence this condition will be while inside of bracket 0. So 0 is a false value, so this while loop will not be executed at all, and compiler will simply print this line, that is hello /n, and it will terminate after that. So technically in this program, this function was not executed at all. And just for the additional information now, if I was not global variable and if it was a local variable, suppose it had a declaration over here simply like int I, then it would hold a garbage value. In that case, this will be an infinite loop. So compiler would have printed hi infinite number of times. Time's up. Here is the answer. We have a forward declaration of a function fun to which an integer will be passed. Then we have our main function where int a is initialized with 3, and then there is a call for this function fun and value of a is passed, which is 3. Then we have definition of our function. So 3 will be passed over here first. Then we are checking 3 greater than 0, which is a true condition. So inside of this if else, there is another call fun minus minus n. So as it is a decrement, so fun2 will be called. So basically we are calling back this again over here, and again this condition will be checked. So n greater than 0, in this case n is 2, so 2 greater than 0. So again this condition will be true, and because of fun minus minus n, current value of n, that is 2, that will be called. Remember that 2 is local to this function call. So now fun1 will be called. So again a fresh execution will be made. Notice that we have not completed the original call that was here. Similarly, even these calls are pending. So as we have sent 1 in the fresh call, so 1 is greater than 0, it's checked. Now one 0 is sent as a fresh call. Now this condition will again be checked. Now it will be false, so printf n will be executed. Now we know that last value of n was 0, so on the output device 0 will be printed because this function has terminated now. So controller will move back to this call. Now because this has got executed, again it will print this value of n, that is 1. Similarly it will complete this statement and this final value n will be printed, that is 2. And after that this execution is completed for this block. Hence this is assumed to be executed and it will end your main function. So output of this program is 0, 1, 2. Time's up. Here is the answer. So we have a structure variable over here in which we have one integer variable I and a float variable ft. After definition of the structure, we have declared a variable x. So x is a variable of type struct. One important thing to notice over here is that this struct does not have any name. But even in this case, compiler will still allow the execution because we have directly created an instance of this structure, so it can be used via this x. Then inside of main function we have x.i equal to 4 and x.ft is equal to 7.96623. So these values will be stored into these structure data members, and after that we are just printing %d %.2f, to which we are passing x.i comma x.ft. So output here would be 4 space, and after that this 7.96623 will be formatted and it will be printed as 7.97. Why? Because we have specified formatting as 0.2, hence only 2 digits will be printed after decimal point, and because we had 6 at this location, hence a ceiling value will be taken. So 97 will be taken instead of 96. Time's up. Here is the answer. Suppose we have two numbers a and b equal to 10, 10. So to achieve this, we will just use a basic mathematical principle in which we will write something like this: minus 10 and minus 10, we get minus 20, to which we will pass minus again. So to this value, we will apply a minus sign again. So minus minus get cancelled and we get a positive number. So if 10 and 10 were your original number, so we have achieved addition without using a plus sign. So to formulate this as a program, we just need to write minus a minus b, which are your two variables, and then apply a minus sign over here. So this is your int sum, third variable, which will store addition, equal to minus, and inside of parenthesis we have minus a minus b. And after that we are just printing value of sum. So this program will perform addition operator without the use of plus operator. I hope you really enjoyed the question. We have many such programming technical questions with detailed explanation in video format, which are packed into a single courseware at codegod.com. Link is in the description, and you can also click on the eye icon to find out the link. Do check it out, it's really useful. You can binge watch all such technical interview questions by clicking on the left playlist, or if you want to learn basics of computer programming, then click list on the right. Give this video a thumbs up so that we and your friends will get to know that you got the right answer. Don't forget to post your comments. Thank you so much for watching. See you in the next coding challenge.